Hello, everyone. Really happy to see you here today on May 4th, and May the 4th be with you. And we have a really special short notice presentation from Alison and Jason, who did an amazing job and had the most loved presentation at PyCon 2 weeks ago or something like that on this exact topic. And so we thought it would be amazing on May 4th to do a rerun. What's better than a sequel, right? Of the show. And so with that, I'm really looking forward to talk about resisting the evil empire, and let's get going. And I brought my little BB-8 to watch, and I need to see if I can have it make some comments and so on, but it's still quiet. So from that perspective, I'm really happy to have you here, Alison and Jason, for the stream. And we're all at Neo4j doing developer relations in the different parts of the world and helping people that use Neo4j to be happy and successful with their work. But before we go to the main topic, I just want to quickly announce that our developer conference, Nodes 2023, has launched its CFP. So if you're interested in attending or speaking at Nodes on October 26th, please go to neo4j.com/nodes-2023, and you get redirected to the registration site where you can save the date, so register for the conference or submit a talk. And we would love to see you there. Last year was a blast, and we also have links and videos from last year somewhere here on the page, I think. Yeah, we would love to see you there, and if you can make it, please do. I'll also share the link in the chat as well, so you can see it as well. And after this announcement, I'll remove my screen, and Jason and Alison, take it away and have fun, or let's hope we can resist the evil empire today.
Nice. Thank you so much, Michael. Hi, everyone. Happy May the 4th. Alison, happy May the 4th to you.
Yes, happy May the 4th, everyone.
As I already know, you're an avid Star Wars fan. And so, today being May the 4th, if you were forced to do a Star Wars marathon, what movie would you start with?
Ooh, I'll be honest, I would probably start Rogue One. I'm not a huge fan of the prequels. I would go Rogue One onward, and I would definitely include some of the new series that are out.
Nice. Rogue One is an excellent choice. It's
Yeah, me too. I love Rogue One as well, so that's really cool. On the same.
Actually, technically, I'd probably start with the Andor series and then go from there.
Oh,
yeah.
Yes, but the Andor series isn't done, right? So there's a little bit of a gap.
I know.
Suspense.
But it's so good.
Nice. Okay, so Rogue One. Spoiler alert for anyone who hasn't seen Rogue One and The New Hope. The two movies segue into each other extremely well. And as most of us probably know, at the end of Rogue One, Princess Leia escapes from Darth Vader. And she has kind of a twofold mission at the end, right? So originally she's tasked with finding Obi-Wan Kenobi, who's on Tatooine. But her ship also gets the only copy of the Death Star's plans, right? So one would think she would probably make a beeline for Yavin or Alderaan. But as we see in The New Hope, she decides to go to Tatooine to complete her first mission. So I'm wondering, in the moment of their escape, what were the plot choices that they had in plot in terms of navigation? What was closer, Tatooine, Yavin 4, or Alderaan? I don't know which one is closest. So how would we solve this? How would we start to solve this, Alison?
Well, I mean, coming from a Python background myself, I would want to know where all the planets were and kind of figure out what the options were. That would probably be my first stop.
Nice. Okay. So I took a look around, and there are a couple community-run sites that compile a lot of Star Wars data. One is Star Wars Galaxy Map, and the other is Wikipedia. Okay, so if we got all this data here, and we've got systems on hyperspace lanes. Allison, what are hyperspace lanes? What are these purple lines?
I'm glad you asked, Jason. So hyperspace lanes are actually paths through space that avoid planets and like different kind of astral occurrences, right? So asteroid fields, different things like that. And so the idea is it's kind of the intergalactic version of the interstate. So it's where you go really fast and there's no stop signs and nobody's going to be in your way.
Okay, so those are probably they're the fastest, safest ways to get from A to C.
They are definitely the fastest way from A to B. So if I were trying to go from if I was trying to get to Alderaan, where the Death Star was, I would definitely want to find the closest hyperdrive lane. Yep.
Okay, excellent. Okay, so this looks like a very, very Waze or Google Maps sort of problem, which which is not my specialty. So I guess if I'm trying to build an app that solves this, the very first thing I would do is gather a bunch of very smart developers and have them essentially build this for us. So
Yes.
What I've done, what I am capable of doing, is making a very simple web form. Here I was using Streamlit to go out into the universe and find ourselves a crack team of Rebel Alliance developers. So I invite our guests here with us live today to, if you get a chance, sign up for the Rebel Alliance. It's just going to ask you for a few things here. Let me blow this up so you can see this. So here, just looking for a call sign so that we can protect your identity from the Empire. An email, you can put in, fake email is fine. But if you would like a giveaway prize later, possibly, then definitely put in an email that you actually check. And then just put in what programming languages you know. Who do you associate with? This being famous Star Wars characters. Which Star Wars characters are your best friends? And then where's your home world? What planet do you hail from?
I'm glad you asked that, Jason, because I really want to make sure that if we're building something for the Rebel Alliance to help them get through intergalactic space, then we definitely want to make sure that we know whether they're Imperial or not, for sure.
Yes. And
so let us know.
Excellent. Awesome. All right. So I'll leave this up here, and in the next couple slides, there will be the link will be on the bottom, and then that QR code will be up in the corner here. Okay. So while our Rebel developer group is assembling here, I'm going to kind of map out one approach I would take to creating this app, as a Python developer. And
long-time Python developer. I'm sure you've got a good way to go about it.
It's I think this would work, and definitely give me tips and stuff here, because you coming from a data science background is going to have probably a much better approach to this. But here, so I'll just lay it out. We'll see. Okay, so here I would start with some sort of straightforward database, probably like a Postgres database, or a bunch of Excel sheets. So the first table I would have is to track all the developers that had signed up, right? So I got their names, their skills, associates, and then I would have a couple other tables, right? I'd have one for all the programming languages, which would feed into that list and would tie in with the users. I would have a table of characters and their affiliation, towards Rebels or toward Imperials, and then another table for all the systems, all that data that we looked at earlier. I would put that all into here. Okay, so like this.
It's a good start.
It's a good start.
Okay. I like your home base on this, Jason.
Okay, thank you.
Good start.
So it's acceptable. All right, good. starting me soft here. Okay. The next thing I would do is kind of work out my top level logic flow. Honestly, this is probably where I should start, but being a developer, I just want to dive in, start capturing data. So really broad strokes, Allison. So here I would basically look at the skills of the incoming developers, look at the associates that people have notated as their friends, and then where do they live, right? So I would put all this into kind of a logical chain, and then I would put them into a pool, and then I'd put like a ranking rubric on top of that, right? So depending on distance from planet, what their Imperial leanings are, how many of their skills match up with what the team needs. And then I would, from that rubric, from some arbitrary scoring mechanism, I would, basically rank them from top to bottom. Is that also an acceptable start?
I think in the logic, you've taken the business problem, which is we have some constraints on, affiliation, programming languages, as well as, where they live and are they close to where we're going to be employing them on this project. So I think the basics are covered, but I'm kind of curious, like, how would you query the data to get to this output? Let's take a look at that.
Okay. So kind of two parts, right? One would be querying the database underneath the hood, right? So here, this is just a kind of a quickie example of an SQL statement for, let's see, what I'm finding basically all the relevant developers with the systems, right? Now this
looks pretty involved.
Is it? Yeah. I mean, we're pulling from quite a few tables, but
yeah. I mean, I think what's kind of lost for me as the data scientist who's always looking for really good proximity, one of the things that's challenging for me in this is that it's sort of like a heavy hand as far as we're not getting as much nuance, right, about who might be the best developer. So for example, we have the name and the programming language, but we saw in the table that we had many different programming languages. And here you've hard coded, well, where their programming languages in this list. But, how many years of experience do they have in each of those? And is that relevant, right? And then we're looking at some of their affiliations, right? And we're looking at some of their friend affiliations. But are we really getting an idea of who are the best developers? Because at this point, we're losing a little bit of the particulars on the languages. And also we have like a really long list that's just ordered by years of experience. So is that really the best ranking? I mean, how effective do you think this approach might be?
Kind of more correlation in some way, right, Alison? Closer correlation.
Maybe. I mean, if we're lucky, right, there's at least some correlation, but it's the total years of experience across all of their languages. What if they've spent most of their time in Java, but we need someone who needs to have a moderate amount of Python? Like, we're not really taking that into account here. So I think it's a reasonable start, but I just don't think it's getting to the real ranking that might fit us best.
Okay. Alison, you had mentioned like the sort of many-to-many problem, which I think is definitely a challenge with SQL.
I mean, and that's what we're seeing here, right? Where we were seeing, if we looked at that table, for each individual, so like Gray Leader or whomever the developer was, we had a list of languages, right? Thank you. So the question is, when we're doing this many-to-many, when we've got that listed structure, we could take this approach here if you were in Python. So maybe you would take this approach where you say, okay, let me make a dictionary where the key is the individual, and then we have a list of their languages. But this doesn't really put us any further ahead than before, because right now we have a good eye for each person, but we don't really see like how they are with each of those languages. So another option might be to dive it down a little bit, and maybe we could make a list of tuples, right? So in this case, we've got developer skills. And in this instance, we have a really good idea of each language as it relates to each person. But now we're missing the aggregate at the person level. So either way, we're sort of missing part of that many-to-many. We either are looking at too detailed an option, which we have here, and we don't understand the person, or in the other case, we look at the person, but we don't really understand the detail of the languages. So the good news, Jason, is that we do have another option. So what we're going to talk about now, I mean, if you're here at Neo4j, I'm sure you're familiar with graphs to an extent, but what we want to be able to do in the actual programming and in the understanding is leverage the many to many. So in our instance, we have a person who knows a particular language, okay? We'll go to the next slide. And in this example, we have, say, the gray leader is a person who knows the Python language. And that seems pretty straightforward, right? Jason, how's this sitting with you?
Yeah, this looks, I mean, visually, this looks great, but, you know, this looks like a one-to-many sort of relationship. Like, you know, we could do this.
This is almost like our list of tuples. How is that helpful, right?
Yeah.
Well, the good news is, let's go to the next slide and I can paint it out for you. So what we're able to do then is to create we are able to create multiple relationships in the graph database. So now we have the gray leader who knows the Python language and also knows, say, the C# language. So what do you think of this?
Good. This, you know, just sort of expanded on the previous one. Still waiting for the aha moment, I guess.
I know, it looks a little bit like our dictionary, right? Where we've got the gray leader as the key, and now we have these lists of languages. So you're probably saying, Allison, how is this helping me at all? This is just another version of the same thing, right? Mm-hmm. We're getting to the good part. So this is where things get juicy. I like to say that with graph, we have the ability to see the forest and the trees. And what I mean by that is, in this case, we've now added the red leader. The red leader also knows Python and knows Ruby. So what we were lacking before is the ability to understand the individual developers as well as the languages themselves. So in this case, we clearly see that Python has more connections to it. Therefore, it's a more common language. And this is a nice toy example. But in graph, we have this ability to manage many-to-many relationships and to not lose out on the detail and not be forced into like a tight aggregate. How's that? Does that make more sense, Jason?
Yeah, so this helps visualize, you know, kind of like all the different developers and all the different languages. But, you know, we have many more use cases, right, besides the programming.
Super tidy, right? So let's go to the next slide. So what we have the ability to do in our data model is we can actually add additional nodes, additional relationships. So what we were seeing in SQL, where we wanted to know where they were from, who their associates were, we can add those in as additional nodes in the data model. So now we not only have managed that first many-to-many, but we have an ability to manage all of the many-to-manys, right?
Okay. Okay. So like this is, you know, this is sort of like, you know, like a high level schema. This makes sense. What does the actual data look like when we kind of all mash it together? So what does it look like?
Well, let me tell you, my friend. Let's move to the next slide and I'll show you. If in reality, if you went to visualize your entire database, imagine trying to visualize the entirety of any database. Here we see that behind the scenes and under the hood is extremely complex. So, you know, visually, do you find this helpful?
Yes, as you know, like if I were just exploring data or just kind of like, you know, kind of manually navigating through things. Yeah, it would, you know, this looks like a great tool to visualize stuff. But, you know, for my app, like I just want to get, you know, I just want to extract, you know, basically lists of data or JSON objects. Can I do that from a graph?
And this is where things get really lovely. Let's move on to the next slide. So in graph, we have something called a cipher query. And it's, you might find some similarities if you've done some SQL, but what's beautiful about cipher is how really elegant and tight it is. So what we're seeing here, if you've never seen cipher queries before, on the right-hand side, is you'll see the word developer in parentheses. An easy way to remember that is that nodes are round, right? And so when you see those parentheses, you're talking about a node. And then what we're drawing is we're really sort of in a way drawing what we're seeing on the left-hand side of the screen. So here in brackets, we have nose. Now that's the relationship or the edge, you'll hear it called. And we then go to another dash connecting to the node language. So in Cipher query, we have on this left-hand side that full data model, but we can dig into just the pieces of the data that we need. In this case, we're saying developer knows language. That's pretty straight and tidy. How's that feeling?
Okay, so yes, I see the sort of the ASCII art relationship, this sort of textual visualization of the graph.
Yeah.
Great. Still, how do I get the information I'm interested from this?
How do we actually use it? Okay, let's move forward and we'll take a little bit. So in this case, the Cipher query will begin to grow depending on the question that you want to ask. So in our case, we're looking at, in this case, a developer node from relationship planet, but we also want where the rebel base is a planet. So we're looking for developers who are from a planet that is also a rebel base. So rebel friendly, right?
Okay.
So we see two different relationships to planet.
And that asterisk in that edge, that's, I mean, like any kind
It
of
allows you
relationship?
to have a number of different types of relationships.
Okay.
Right. So maybe it's, like is a rebel base. Maybe you don't necessarily remember what the relationship name is for rebel base, but this will say that if there's a relationship between a planet and a rebel base, that will come in your query.
Okay. Okay. So this looks,
But that's
like
only in the it's only in the visualization, right? So the star in Cipher means actually any distance. So you can basically take any distance and if you
if you have multiples, go ahead, Michael.
Yeah, so if you go like in Cipher, so this is a good visualization of like allowing any relationship type. So you can also in Cipher you can just leave off the square brackets and don't put anything in. That also means any relationship, but the star actually means any hop. So it's actually connected to a rebel base. So it's basically in relationship. This planet is in relationship to a rebel base. So that's basically associated directly or indirectly with a rebel base. So it could be like something that's, one hop out or two hops out or three hops out as such, which is also really cool and powerful graph feature as well.
Yeah, and it's a way that we know that they can get from this planet to a rebel base or from a rebel base to this particular planet, right? So we know they can get to us. They're not off the grid, so to speak.
Yep.
Okay, so this query now is like, I can see where like this would be a much more complicated thing to do in SQL, right? Like this is a dynamic length pattern that we're looking for here. So great, it's fantastic. I get that. Question still remains: how do I get the information I'm interested from this query?
This is all well and good. So as we look at the more complete Cipher query, what we do is we have something called, in this case, we're looking at match. So match means retrieve, right? It's similar somewhat to a select in SQL, or so where we say, okay, so find the pattern, developer, friend of, associate. Right? Find that pattern. And in this case, we are going to create like an aggregate. So with average, so we're going to take in each of these nodes, they can have different values or properties. So within the associate node, we have something called affinity, and that's their rebel affinity. So let's just say like it's between 0 and 1. So if you were Darth Vader, your rebel affinity would be 0. If you were Luke Skywalker, your rebel affinity would be 1. And we have assigned an affinity value for each associate. So what it will do is that for that developer, it will go out and collect the affinities of all of the folks that they have the friend of, and those associates. So all of those associates of that developer, and then it will take those and get us the average of all their associates. So what we want to be able to do is where the average of all of their associates overall is over 0.5, We want to list just those developers. So in this case, we're saying, give me the developers where the average Rebel affinity of all of their associates is greater than 0.5.
Okay. All right. Okay. So, and then the developer that's returned, if I put this into a driver and I fire off this query, I get back, if I'm looking at the docs right, I get back a list of JSON objects, right?
Yes, you do. And that's what, and you want to be looking at the developers that it's going to be returning to you.
Excellent. Okay. All right. So I took all this, put it into a Streamlit app, and I've spun up a Rebel developer app based off of everyone who had signed on. So this is the app here. It's just very straightforward. I have the secret location of our Rebel base, which happens to be Yavin, and all the languages of all the developers who signed up in the system, and it's just ranked by highest count. And then I've listed let me go back here. So I've got this data on the upper right, and I've got this manual search panel that I've created that will just take certain data and feed it to the query, right? So I've got, how big do I want the team? Let's go with a 3-person crack team. Programming languages. So I can see Python was a big one. I'll put JavaScript and maybe we'll put in TypeScript and skip over some of these other ones. Okay, so let's say the team that we want to put together, we're going to use Python, JavaScript, TypeScript, and we are okay. So Tatooine is one option. Let's choose Tatooine as our home base. Let's stay within 10 hops, and we'll just go neutral. Like, I don't know how many developers we've got here. So based on this data, I'm going to search our database, which I've now moved to a Neo4j instance, and see if anybody shows up here. Okay, so I got a couple of developers that met this rubric that I have here. So first one that I've got listed here is Red Dog, who happens to be from Tatooine, knows JavaScript and Python. So, and associate R2D2. So this person seems like a pretty solid fit.
Yeah, for sure.
Right. Excellent. So
totally.
we've got
well selected.
Nice.
You're
so we
hired.
got hired.
Red
So
Dog is it.
Exactly.
hired.
Sign
Exactly 3 folks. So when I was playing around with this earlier, I did notice that, if I happen to choose a combination that might be kind of unusual, right? So let's say, let's say I just have TypeScript and I have some far off planet. Let's say you see this Jetta in here. Okay. And I want to be still within 10 jumps, and I search. I don't find any developers, right? So there are actually a lot of particular scenarios where I just won't have any developers that kind of meet my needs, right? So
and that's where the beauty of the constraints arrive, right? So depending on what your requirements are, how hard are those constraints? Where do you have wiggle room or not? Personally, I'd give more wiggle room on how long it takes somebody to get there than on their affinity score. But that's just me.
Okay, so we can just adjust these sort of metrics here. One thing I did do, kind of harking back to at the start of here, trying to figure out who's who, I ended up creating also just a ranking system based off of the rules rubric that we talked about before. So just randomly assign points, and then this way I don't have to manually look for combinations. I can just have the system tell me, really you should be considering using Python, JavaScript, C. These are your top languages, et cetera, et cetera. Okay, so
and the languages that we're dropping in here are just, random languages that we chose. So I know there was a question in the chat asking if to be an expert in graph data science, if we need those particular languages. And no, we're just using them for the purposes of this exercise.
Nice, thank you. Cool. Okay, so this looks good. Allison, can we go with these developers? Let's see.
Yeah, I feel really good about who we came up with. So I think this is great. I think we know that we've got some folks who have the languages that we want in order to build this ways for Star Wars. So that's what we're really looking for, is people who can help us build this app that we need so we can get Princess Leia where she needs to go with those plans.
Nice. Okay. All right. So let's go back to this navigation app here. Okay. So just to recap the data that we managed to get, which was a lot of data from both the Wikipedia API and the Star Wars map, Star Wars Galaxy map. And so one thing I did have to add to this data was these connections. So let me see. I'll just show you the map here. Was in all the data that we had, we didn't have like this data, right? The hyperspace, the relationships, right? So Coruscant is on a hyperspace link connected to Alscan. And so that data was not in the data that we were able to get. So I went and I created a data set that included all these relationships and kind of expanded on what this data had, so that we would have that data to put into the graph database. Is that good?
Do you have a distance on that as well? How far they are from that? Do you have the distance information as well?
Oh, so yeah, we have coordinate data, right? That came from Wikipedia, and so both data sets.
So you can compute the distance basically between the two.
Yes, exactly.
Yes,
Nice.
absolutely. So the question, Jason, is now that you have this data and you want to go ahead and build this, how might you put this together? Like we're seeing here at the bottom, one possibility. Let's just say you have your hyperdrive lanes. You seem to like these dictionaries. Is that your usual go-to when you've got many to many?
Dictionaries are my go-to. It's
Mr.
good.
Dictionary.
I will say the dictionary of dictionaries is one of my favorite data structures outside of graph. Just saying, it's a tool.
It's a
tool,
document,
and
yeah,
it has
it's
its
a nested
place.
document.
So
Nice.
so my question then, Jason, is if you have this data structure and you're programming in Python, how would you actually come up with the direction of, if I want to go from A to B, how would you code that? What might that look like?
Right. So again, I'm not a GIS expert, so I'm sure there is a much better way to program this. But me being a fairly straightforward developer, I would probably sit down and start working out basically a lot of if-then statements to connect all the dots, right? So if I know I'm starting at a particular location, I'll pull that up, find what it's connected to, and just kind of follow all those hops and compile a nice fat dictionary with all the path options and the count of hops to figure out which one is the shortest. Yeah.
And you have to go into the dictionary again, time and again, to find out for the next hop what it is connected to, and then again and again, right? You always have to do this kind of dictionary lookup for each step.
Yeah,
as well.
and you have to know like which is the shortest path, right? I mean, we don't want just any connection, right? We want the most expeditious. So as I'm looking at this right here, we're seeing this looks like it covers just it mostly if they're on the same hyperdrive lane.
Yes,
yes, and we have many hyperdrive lanes, and we have planets that are not on hyperdrive lanes. So it seems to me there's a lot of work hard coding and a lot of work like contemplating edge cases. And I can imagine that this approach would be how many lines of code do you think it would take for this best path function you're working on?
A few. I'd probably put a few recursive functions in there to lighten the load a little, but
true.
Some lines.
It might be some. And then let's just say the data changes or the nature of hyperdrive lanes change, and you're trying to optimize. That's a whole other set of if-thens, I suppose. Yeah.
Yes, that's true. Handling different rule sets, that would be a wrinkle I would advise against.
The question
I will be honest
is
with you. I think that this was, the Empire's plan all along to get the rebels so busy building if-then statements that they don't have time to actually do something that could be effective. Because this would probably take some time, I imagine. Yeah.
Yes, which is why I have a crack team of 3 other developers to help create all these if-then statements.
So Jason, let's move on to the next slide. So let's just take a minute and tell me like you did before, you had a way you would approach it, and then we looked at your business logic. So what are we seeing here?
So we're seeing, a diagram, a workflow diagram of a possible solution, right? So, I got a starting point, run through a lot of different functions that are calculating different paths until I have gotten to the end location. And then, so this sort of workflow chart is what I would use to guide creating all those functions to generate the data that goes into my master dictionary of dictionaries.
Okay. I have a question for you, Jason. Is anything about this layout look familiar to as anything we've seen today? Looks similar to something we've seen?
Yes, it looks a lot like your graph diagram from before.
Exactly. So here's the good news, folks. We have our original data model. We are still using that same data model, but what we're adding now is we're adding new relationships. So as Jason mentioned, we've got those connections on the hyperdrive lanes. So we've added a series of connections among these systems and planets. The first is connected to, and this connected to relationship is when two planets are next to each other on the hyperdrive lane, they're going to have a connected to. But not every planet is on a hyperdrive lane, right? Not every town is on the interstate exit, right? So if you're a town that's over, you're going to want to go to the closest exit on the interstate. So we also have something called near. And so for any planet that's not on a hyperdrive lane, we've created a relationship near. So exactly like Michael was saying before, we leverage those coordinates we have for each system to calculate the distance to various planets, and we find which system on a hyperdrive lane is the closest to this planet, and we create this relationship near. And what's great about Graph Database is that it's a very simple formula to create these types of relationships, right? You don't have to go make a whole new table. You can actually write a query that based on certain properties, you can create that relationship, right? So Jason went through and gave us those connected to relationships when he went through and was building that database. So we had those. But the near connections, we actually leveraged what was in the data itself to create those relationships. So the wonderful thing is how flexible the graph database is. Because I know for myself, when I'm building a new database, there's so much time spent when you're doing tables and columns on your EID or your ERD and, normalizing the data. And then what if something comes up and it changes, right? We've had a material change to how we're leveraging this data, and we didn't need to do much at all to create that information and make that available. So how's that sitting with you, Jason?
Okay, yeah. So again, visualization. This data model looks super awesome. So I'm curious though, like, so I have this giant, network of functions. How does this in any way
Is it going to
make
help
that
solve
simpler?
your if-then statement? That's what you really want to know. Can you get
That's what I
out
want to
from
know.
under the Empire's crushing if-then load? Let's take a look at the next slide. So here's the good news. This is all that you need in the code, right? You would make the start point a variable, you'd make the end point a variable. So what we're seeing here is we want to match the start of the system. So we're looking for the system that has the name property Scarif. We're also looking for the system that has the name property Alderon. And then to create the shortest path equals shortest path. So there is an algorithm called shortest path in Cypher that will get you the shortest path between two nodes. When we look inside the parens of that algorithm, we see start, which is Scarif. We want to see that it has a relationship connected to / near, which means either connected to or near. And then the star, as Michael said, is from 0 through 100. So anything that's within 100 hops between those two, and then it gets us to end. Okay, so the end is Alderon. So node, relationship, node. So in those square brackets, what we're doing is providing sort of constraints, as it were, on the relationships between those two particular places. And those are the paths that we're going to get. So in shortest path, it's going to give us the shortest path through the system between those two planets that you were asking for. So would you rather write this, or would you want to go back to looking for all your edge cases if you're if-then statements? Because, you do have a choice.
Is it really true? Well, I do love my if-then statements, but this, it's in terms of brevity, this is highly impressive.
Maybe you didn't need as many developers as you thought after all.
Oh.
All right, so let's move forward.
Cool. Awesome.
And why don't you tell us what we've got here, Jason?
Awesome. Thank you. So Alison, I took everything you've taught me. Real briefly. So, in playing around with this query, I do understand that when I return a path, it gives me a list of dictionary objects, right? That is related with the snark connected to an end. And also, if I didn't, include the connected to and near relationship types as you have here, I will get all sorts of interesting shortest path hops that I hadn't expected, but after looking at the data, it makes sense. So connections between like a system to a person, right? Like, so this person's from this home planet and this person knows this other person. So the database actually will return those shortest hops if you don't specify, the type of relationships. And for our hyperspace navigator, we're of course only interested in the hyperspace lanes and locations. So that addition to the relationship was key, and was kind of a fun discovery process to exclude those. Okay, so here I've got the hyperspace lane app now built, and we can see here using the old tried and true matplotlib to visualize all the systems that we have in the database. So everything here that's gray is a system that hasn't been listed as being connected to another one on a hyperspace lane. Admittedly, I didn't get around to doing all the connections, just the major hyperspace lanes, which are notated by the blue systems. So the blue systems are on a hyperspace lane connected to its neighbors. And then just for convenience, I made some systems white, and those are systems that show up in one of the major movies. Okay, so basic scatter plot is just visualizing what's in the graph database. Here up at the top, I put in just a few drop downs for determining, or helping you select planets you want to go from. So if we go from Rogue One, Scarif to Tatooine, we can see a course plot here. So we can see here the map updates to where the systems are. We can see Scarif and Tatooine are actually not that far apart. And if I plot a course, I'll update the map with, now this is just updating the plot with the return path data. So we got Scarif all the way down to Tatooine. It is 9 hyperspace jumps away. And we've got a list of planets that I'm not familiar with, but we can see it's not too far from Tatooine. So, back to the beginning, I had an earlier question like, okay, Tatooine, Yavin, are they same direction? Are they close? So here, if we were to go from Scarif to Tatooine, right, it's 9 hops. If we were to go from Scarif to Yavin, so if Princess Leia had decided instead to make a beeline for the Rebel base, we can see on the map that Yavin is considerably further away from Scarif.
For certain.
And whew, okay, so that's quite the run. It's 49 hops from Scarif to Yavin.
And was that her original intention? Was she headed towards Yavin or Alderaan? I'm trying to remember.
So that's the question, right? So, I rewatched Rogue One, and, there's a bit as the fleet is going to Scarif that Mon Mothma is asking Bail Organa, like, could you, dig up your old Jedi friend to help us? And he's like, sure. I'm, basically alluding that he's going to send his daughter, Princess Leia, to go get him. So he's on Tatooine, right? So that's her primary mission in the movie, is to go recruit Obi-Wan Kenobi.
Got it.
Her ship also happened to have had the plans, right? So she has she had quite a few options: go to Yavin, go to Alderaan, go to Tatooine. And from this, so we can also plot to Alderaan, which is also far from Scarif. So this one a little more straightforward, but this one is 31 hops. So Tatooine, of all her choices, was definitely the closest place to go first. Right. And okay, so under the hood, let me show you the code to make this work. So the course plot is let's see here. Oh, this is the Rebel Developer Network. Is right here. So if you ignore this line, so this is just the query statement that you gave me. I just put this in. It returns a path, and then I just took the resulting JSON data and just put it into a Python object that I have for making it easier to visualize this. And that's it. That
like
one
it.
query basically powers both this and this.
Yeah, I mean, what I love about it, but I have a question, Jason. What if there was an Imperial base on that run? What if you wanted to possibly not go in a particular direction?
Right.
What if there was a planet you wanted to avoid?
Right. So let's see here. Let's go. What was a good system here? So yeah, right. So what if she intended to go to Alderaan, right?
Yeah.
But
if it were me and Darth Vader was chasing me, I'd want to go home. I'm not gonna lie. I'd be like, all right, you go find your rebel guy. I'm headed home.
Right. You could come out and find Obi-Wan later. Right. So
Yeah.
if Scarif, which was I think over here. Right. So let's say she couldn't go this direction, right? Let's say there's a huge Imperial presence on Manda. And so she doesn't take this shortcut here. Let's say there's also an Imperial presence on Malarian. Okay, so what I've done is I've added some advanced options to the plotter. So you can put in planets that you want to avoid, Manda and Malarian. So I've put these two in here. Plot that course. And oh, I'm going from the wrong planet, aren't I? Oh no, yes. So say she was trying to get to Alderaan. So this would be her course around those two systems, which would be a hefty 49 jump hop. But it would take her along the route of getting to Tatooine. So maybe that's what happened. Maybe she was trying to get to Alderaan. She was just like, I'm done with this mission. I'm just going home. But like, hey, there's a Imperial fleet at here and here. I might as well stop in Tatooine and get me an old Jedi friend.
Absolutely. So Jason, it looks like you and your Rebel friends built ways for the Star Wars galaxy.
Oh yes, no,
Go
we did. Just to kind of cap this off here. So this is the line that I added to make the system avoid certain systems. All right. So it's an extra where clause that's looking through the shortest path that's being brought back, and just checking to see that none of the nodes in those paths has the property matching the system that we're avoiding, and that allowed this. That's all it took to expand this system.
That's a really tidy cipher query. I like it.
Thank you.
Yeah, really powerful. And actually, what's also really nice is even if you're not a developer, you can look at this and understand what's happening there, right? So basically, if you were like an admiral or like an troop leader or something like that, then you could look at this and you would still understand what's happening here, right? So because you don't lose the forest for the trees, but you actually see what's happening as such.
Exactly.
There's also, by the way, an all shortest paths function which gives you alternative paths with the same length, so you can basically pick and choose which one you want to take based on other aspects as well.
Yeah, that would be a thing I'd like to do in the future, right? Is add in those distance calculations in time. And I know Wikipedia has all the Imperial leaning planets, the Rebel leaning planets. So putting that all on this map would be kind of a fun.
That would be really cool. Yeah. By the way, someone asked Jason if the code for the Streamlit app is open source, if you have it available somewhere, but I guess you have it on the.
Oh, yes.
I
do have it on GitHub. So I will update. So our link pages, which all the QR codes go to, I will add it to this. And then, so if you just check back later today, I'll have those GitHub links there.
Super. Thank you.
Apologize in advance. It was, conference-driven development code. So,
That's the best. That's the best.
Hey, sometimes the rebels just need to get it done.
That's
Exactly.
right.
You have no time to waste, right? So it's urgent.
See,
Awesome.
and when you have such clean, elegant code, it makes it so much easier to have time to refactor, for sure.
Oh, that's true.
Otherwise, you'd still be on your if-then statements from the first method.
Exactly.
That's a good point. All right, Allison, do you want to recap for us everything? Well, not everything that we went through, but
I can certainly talk relationships and flexibility, and I'll leave the droids up to you. The real thing that we want to make clear and really empower everyone with today is that the great thing about graph database, and in this case graph data science, is that it allows you to manage many relationships in your code, as well as just in your ability to extract options in a very clean and elegant way. So you really have a power over the many to many that is much harder to attain through more traditional Pythonic or SQL methods. The other thing that we talked a little bit about is really the flexibility of graph, the ability to add new nodes and relationships at any time. One of my favorite tools is something called APOC Refactor. And, you can take something that maybe it's a property of a node, right? So let's say we have an XY, a latitude, and it wouldn't be that long, but, let's say we have an XY in intergalactic space. We can leverage those properties of the nodes to create, a new relationship that is the distance to. So we can have a relationship that's, say, distance to every planet. Or we can say, let's now add in a node for the hyperdrive lane. And we can create connections to that new hyperdrive lane. So the flexibility of the database itself to live and evolve as your use of the database evolves, and not to really be constrained. So those are really the two things we really wanted to make clear for you today, is that ability to manage many to many, and this knowing that you don't have to take all of the edge cases into account before you put your database together, and you're not going to be confined by them because the database itself is highly flexible.
Nice. Yes, and droids love graphs because it gives human developers more free time, which allows humans to spend more time with droids to give them nice oil baths, which all droids love.
Every droid loves a good oil bath. The spa for droids.
Exactly. Or you can find some new spare parts for your droid, which would also be appreciated, right? So that's always some extension or booster or something like that. Exactly. Cool.
Okay, so I do have a spare galaxy map that I would love to send to one of our top ranking developers here. I'm gonna have to filter this a little bit though here. Let's do it from yesterday. So Rogue 4. So somebody who signed up as Rogue 4 today. So I have your email address in the database behind the scenes here. So I will reach out to you to send you that galaxy map. Do enjoy. Let's see. Do we have any last questions in the chat, Michael, that you might have missed?
Yeah, there were some questions which we tried to answer. So one was, for instance, is affinity a cipher function? As such, I'm not sure, Alison, if you want to answer that.
Yeah, so one of the questions that came up was what was the affinity score part of Cypher? And so the affinity score was actually something that Jason put into the database itself when we were adding in the characters. But the aggregation of that property of the character is done in Cypher. So each individual character in the database has their own affinity score, but the average of a developer's affinity, of the developer's associates, their affinity scores is the calculation that we did in the Cypher itself.
Yeah, and just to allude on that, the affinity score was, it's a convenience, right? So the better way to do this, right, would to have put in, basically a knowledge graph into the database of interactions between characters, what they've
Yep.
done, what movies they're in, and to use some special magic to really tell us what those scores are.
Yeah. I mean, we touched on just a few things today to make it clear, but the world of graph data science is very large, and you can use things like, say, community detection, right? So maybe you want to run community detection to maybe find somebody who spends a lot of time with the rebels, but is technically in the Empire. So maybe you want to pull those folks over to the bright side, or maybe there's someone who you think is a rebel friendly, and you find that they're actually spending a lot of time with the Empire, so maybe they're really a spy. So there's lots of other ways that you can leverage graph data science within this particular use case, and you can use that to create, like Jason said, a new variable. You can use graph data science to assign, say, a community like that someone is assigned to, or what their sort of centrality or importance is within the group itself. So I want to find the most influential character who's got a mid-range affinity score, right? So you can use graph data science to do that as well. So there's a number of algorithms that are specific to graph that you can leverage. We talked about shortest path, but really there's so many. And stay tuned, because we're always bringing in new things. We can tell you more about them as we go forward.
Yeah.
There was
So
one other question. I don't know if you saw that one, Michael, from Eshwar.
So Ashwa asked about if you would use Cypher or SQL on Neo4j or graph databases. So for Neo4j, we use Cypher because it's kind of optimized for graph questions and graph patterns and graph operations. So you wouldn't use SQL on Neo4j, because as you also seen in Jason's first example, the SQL becomes pretty cumbersome, and especially if you have these variable length paths, then you have to write common table expressions for recursive queries. And I think there's only like a handful of people who really enjoys writing recursive SQL queries as such. So from that perspective, here we would use Cypher from that perspective.
The other thing I wanted to say about Cypher and what I like about it is that, as far as, picking up a new language or picking up a new query language, I found it, when I was learning it, to be pretty intuitive. It does call on some things that we've seen before, like the where clauses and things like that. So I think, if you come from a SQL background, I don't think that it's a huge lift to pick up Cypher. But I don't know. What do you folks think? Jason, Michael, your thoughts?
I thought Cypher was super easy to pick up. Like, it's once you understand that you're querying for patterns rather than individual rows of data, it opens up the door, because not only can you find a pattern, but you just change the return statement to find what bits of information from that pattern you're most interested in. So the combination I just thought was really powerful and really flexible.
Yeah, thank you for the praise. So back then when we designed Cypher, we actually took a lot of inspiration from other languages that are very human friendly. So we tried to make Cypher really a humane language that makes it easy for humans to read and understand, and also to write, and still powerful at the same time. And we also learned from some of the mistakes that that we feel SQL just added more burden. So for instance, Cypher doesn't have a group by clause or a having clause, because your Cypher is more composable, so you can just do this inline, and you don't have to repeat yourself and things like that. So we try to really make it as user friendly or as developer friendly as possible to learn and use as well. So it's also easier to maintain and share with others too. So thank you for the praise.
Yes,
so
thank you, Michael. I know you guys. I mean, having Michael around, he's been there, so he helped build what we're looking at today. So yes, props and
it's really cool to see it used in so many. Exactly. It's cool to see it used in so many places. So, and we at time, thank you so much, Alison and Jason. This was a wonderful exploration of the Star Wars universe and what you can do here with graphs. And, the universe is just a big, gigantic graph of connected planets and galaxies and, people and characters. No matter where you look, it's all connections and relationships. So make sure to spread the love for relationships and show everyone the power of graphs. And with that, may the fourth be with you. And thank you all. Don't forget to register to notes or submit a talk if you have something. And otherwise, there are more live streams coming up in the next few days. So make sure to check out also what's coming up. Yeah. Thanks a
for
lot.
having
Have a
us,
great
Michael.
day,
We look forward to
everyone.
meeting
Thank
with
you.
Bye.
Bye.